So no new transformations. We're going to stick with reflections, rotations, and translations for a while. We'll stick to those. No new ones. What I want to do today is just show you some new vocabulary, a new symbol too. If you remember yesterday's quiz, I forget the exact ones, but you'll remember that last one was part A, do this, part B, then do this, and then part C, then do this. We remember that one from yesterday's quiz. All right, I want to do the same thing today, but I don't want to write it as part A, B, and C. I want to write it as one long full problem, and that's it, instead of breaking it up into parts. And what that's called is a composition. That's multiple transformations happening at a time. So let me show you an example of what it looks like first. All right, let me show you an example. Let's start with this. Capital T tells me I'm going to do what? Translate, and we'll put two numbers here like we usually do, 2, -6. All right, 2, -6. And then you're going to see a new symbol pop up now. New symbol. Looks like a degree symbol, except it's right in the middle here. That is the symbol for a composition. Again, 2 or more happening at the same time. All right, after my composition symbol, you'll see another transformation. Let me put lowercase r for what? Oh boy. Reflection, and I'll put y-axis here. And I'll just leave it at that. I could keep adding more, and I could keep, putting a symbol, writing something else, putting the symbol, writing something else. And then what you'll see in parentheses is usually what we're going to do it on. So I'm just going to make up a triangle ABC. Now, most of you would say, all right, hey, I read books left to right. So that's probably how I'm going to read this one. I'm going to take triangle ABC and move it right 2, down 6, and then I'm going to reflect it over the y-axis. This is the catch, and here's what you got to remember. I don't read it left to right. These compositions are read right to left. I know that seems crazy, but this is how I perform them. I go from the right all the way to the left. All right, right to the left. So really, I'm going to take triangle ABC and do what with it first? What's the first one I'm going to do up here? I'm actually going to reflect first, take those coordinates, keep going to the left and translate them. All right, so just one thing to keep in mind, that when I do a composition with my little degree symbol here, it's done all the way to the right, working my way back to the left. All right, so let's try one right now without coordinates. I just want you to draw for me. Just draw. So everyone see my composition right here? I'm going to perform on the letter B. How do I read them again? So if you take the one on the right, what's it telling you to do with my letter B right now? If you start all the way to the right, what do I want you to do with the letter B? 9, what's all the way to the right? Reflect over line L. So everyone do your best. Capital B reflected over line L now. And I'm not going to be critical. Don't be critical of mine. Well, your upper hump is smaller than the lower one. All right, get over it. So I reflect it. Keep working your way to the left. Now what do I want you to do with the B you currently just drew? Keep working your way to the left. 7. Keep working your way to the left. Now what I want you to do? Reflect it over line M. So take the B you just drew, reflect it over line M, and draw me your final B. And there it is. Okay, so just how to read it. Okay, final thing, and I will ask you to do this tonight on the homework a few times. We just did, how many transformations did we just perform? How many transformations did we just perform here? 2 reflections, right? Can you do it in one move? What could I have done to the first capital B to end up with the one I just drew? Instead of doing 2 reflections, that's the same as doing blank, this. So how could I have gone from this capital B to your finishing one? Take a look. Name something I could have done. So instead of doing 2, Mr. Carlino, I could have just done this once. How could I have gotten it there? 14, nope. What could I have done? Try that again. 2, what could I have done? That's it, translation. Good job. All right, so I didn't mention this at the beginning, but L and M are parallel. Anytime you reflect over 2 parallel lines, that's the same as, Molly, one more time. You just do a translation instead. Yep. So translation. Good work, good work. All right, let's cross the lines now. Let's make them intersect. Let's make them intersect. Still doing, everyone see the composition written down here? Right here? Here's my composition. What do I want you to do with C now? What's the first thing you're going to do with my capital C up there? 14? 9? What do I want you to do first?
Reflect it over line L.
Everyone go ahead. Good job. Whatever's to the right. So everyone go ahead, draw capital C reflected over line L. So fold it over. What would it look like on the other side? Then take that C, keep working your way to the left. And what would I like you to do to that C? Let's hear it from 3. Take it, reflect it over line M now. A little bit tougher, right? Because it's diagonal, but flip it over line M. What's it going to look like? Flip it over, do your best. Look something like that, maybe. We're in the ballpark. All right, same question I asked above. You guys just did 2 transformations again. How could I have done it in 1? How could I have done it in 1 transformation? So when I reflected over 2 intersecting lines, that's the same as just doing a what from the beginning, Mr. Carlino? From here to here. Not a translation anymore. Because remember, translation would be up, down, left, and right. And this C is a little tilted from the original. All right? So what could I have done right from the beginning? 5? From here to here, what could I have just done? Remember, you got 3. 3 we talked about. Reflection, translation, rotation. How could I make that C look like that one? Rotate it. Everyone agrees? I could have rotated it, and it would have matched up. All right, so we got 2 right now. 2 reflections over parallel lines equals a translation. 2 reflections over intersecting lines gives me a rotation. One more I got to talk about. And that is called a glide reflection. Glide reflection. It's got the word reflection in it. What do you think glide represents? Glide. Out of the transformations we've talked about 3 of them. What do you think glide's the most closest to? Luke? A translation. So this is going to be a translation and a reflection. Order doesn't matter. What's it look like? You're about to find out. Everyone out in the hallway. Here we go. Out in the hallway. Let's go. A little quick feel. All right, so there you go. There's a 3rd composition where I can slide and translate called a glide reflection. But you just can't use that on any reflection and translation. You have to slide parallel to the line you reflected over. All right, all good? Okay. So here's what I want to do. I want to actually do a composition on a graph now instead of drawing capital letters. I want to do a composition on a graph. So I'll give you guys a second here. Can you guys graph triangle TEX for me before we perform the composition? All right, so go ahead and graph triangle TEX. Let me just write this out so you can see it. We see the symbol right here, right? We see the symbol. It says compositions. So now I'm thinking, how am I going to start reading this? Whatever's all the way to the right. And what's all the way to the right? Read that for me because it's in symbolic form. Read that notation for me. 5 again, Jackson. What's the T stand for? Translations. The numbers tell me the direction and distance, so I'm not going anywhere here, but what's the -5 tell me? Everyone, take your triangle. Go down 5 first. Got to read whatever's to the right first. Whatever's to the right, so go down 5. And we're labeling it T prime, E prime, X prime, right? Because we're doing a transformation on it. Keep reading to the right. Now, whatever triangle you're on, keep going to the right. And what are we going to do with this triangle now? To the left, excuse me. 11. Keep reading to the left. What's my next move?
You're going to reflect it over the x-axis. Oh, the y-axis.
Y-axis, yep. So everyone take triangle, the prime one, and now reflect it over the y-axis. And now that's going to be called what? How are we going to label these points? Double prime. Yep, double prime now. Good. All right, and there you go. There's the composition done. Okay, so you guys can understand how I'm taking parts A, B, and C and just putting it into one now and rewriting it. All right. All right, 2 other things we got to talk about before we wrap it up here today. Orientation of a figure. Orientation. I just need somebody to do a quick favor here for me. 3. Where's 3 in the house? 3. All right. Just do me a favor yourself. Name this first triangle however you want. No.
Oh.
With the actual letters that there, but I just don't care.
TXE.
TXE. Okay. So Stella's decided I'm going to name it TXE. So she went from T to X, X to E, E back to T. What direction is that going? Clockwise or counterclockwise? This is going counterclockwise. All right. So the way Stella labeled it, we say this has counterclockwise orientation. All right. Counterclockwise orientation. Now, if she went, TEX, we'd say clockwise. All right. Depends on the order you pick them. So orientation is the direction of the vertices. Direction of a figure's vertices. But I still have more for you. Please let's respect Stella's decision here and go that same order every time. TXE. Go to the prime one. Go TXE for me. What's the orientation here? What would be the orientation here? Also, counterclockwise. So these 2 triangles have the same orientation. Everyone good? They have the same, the first 2 triangles have the same orientation. Let's go to the final one. Let's keep going the same, what is it, TXE? Ooh. What do you notice about the orientation here now? What's the orientation for the double prime one? Clockwise, right? Oh, so now how do we describe the orientation of the previous 2 and the last one? Do they have the same orientation? No. So we say they have opposite orientation. One's going one way, the other triangle's going the other way. Opposite orientation. See the difference? Everyone good before I get into this next part? These first two triangles have same orientation. The first and the third have opposite orientation. All good, because now I'm going to challenge it. Rigid motions. Let's go back and talk. I know I haven't talked about that since day one. Rigid motions, those are transformations that do not change the figure's size or shape. We've talked about 3 of them so far this unit. Name one of them. We've talked about 3 rigid motions already this unit that does not change the size or shape of an object. Just name one of them, please. 16? Is there a 16? 16, going.
Oh, sorry, my bad. Isn't one of them like translation?
Okay, let's talk translation first. That is a rigid motion, correct. Here's what I want to know from you and your group. When I translate a figure, will it result in the same orientation as the original or opposite orientation? What do you guys think in your groups? Same orientation or opposite orientation when I translate a figure? And here's a hint. You did it already up above. Here's a hint. You did it already. You did a translation above. Same or opposite orientation when you slide a figure up and down. 19? Same or different?
No, it's the same.
Same. You're right. It doesn't change the orientation. So we're going to put translation right here. A rigid motion with the same orientation. Yep. No, we're not even going to talk about it because it's not a rigid motion. A dilation would change the size of a figure. Rigid motions do not. So you will not see the word dilation listed here. Okay, a dilation is not a rigid motion, again, because it changes the size. All right, 2 more we've talked about. 2 more rigid motions which do not change size or shape. 2? Okay, let's talk rotations now. Rotations are rigid motions. Ooh, we didn't do that up here, so you guys are really going to have to think about it in your group. When you turn a figure, will the orientation change or not? Think about it. Draw it, whatever you need to do, right? Will it change? Will rotating a figure change its orientation? From clockwise to counterclockwise. Clockwise, counterclockwise to clockwise. Think about it. Draw one up. Draw a triangle right now. Label it ABC. Determine the order of the vertices. Turn it. Do the same order. Did it change your orientation or not? I'm teaching. Sure, you can come back later when I'm not teaching. All good? What do we think? Did it change or not? 8. Same or opposite? Does not change. Good job. It stays the same. So we're going to put it right here with same orientation. Good work. A rotation. Good work. Does not change the order of the vertices. And then we had one more. Translation, rotation, and then one more that does not change the size or shape of the figure. 18. Reflection. Reflection. Would that change orientation? I'll let you guys decide. Again, we did it up here. We did a reflection up here. Will that change orientation or not? A reflection. Nine?
Yes.
Yes, it will. So we're going to put it right here. Rigid motion that is an opposite orientation. Good. Now you guys will notice we went through all 3, but I still have a missing blank, right? Well, that's because we're not going to talk about it until tomorrow. All right. With a reflection, can you just do me a favor, a little bit more detail? I have only had you guys reflect over a line reflection. Tomorrow, I'm going to show you how to do what's called a point reflection, how to reflect a point through another point. And we'll notice tomorrow, and I'll bring it up again, it does not change orientation when you reflect through a point, but it does when you reflect through a line. So all good on orientation when it changes, when it doesn't change?
Yeah.
We're all good, because you and your group are kind of finishing the notes right now. All right, I have a bunch of figures on this graph. Using reflection, rotation, translation, or what we did in the hallway, a glide reflection. Tell me how we get one on top of the other. Let's go. Tell me how we get one on top of the other. One per problem. You can't do a rotation, then a reflection. Just one per problem. How do I get one on top of the other? For number one, how do I get ABCD onto GHCD? What do I got there? 12?
Oh, sorry.
That's all right.
Reflection.
Reflection. Yep, good job. Reflection. All right, number two, map them up. How? 19?
Rotation.
That is a rotation. Good. All right, how about number three? How do I get those two onto each other? 13?
Glide reflection.
Nice work. Glide reflection. You had the slide. Everyone see you slide parallel to where you're reflected over, just like you did in the hallway. And then finally, number four, what do we have to do? 10? Translation. All I needed to do was slide that figure over. All right, I want to go over the couple things on the homework with you so there's no confusion coming into tomorrow. First off, I do not want you to do number 5, so you're welcome. One less problem. All right, take a look at number 2. Just so we're clear on the directions. Don't do number 2 while I'm talking about it, please. So number 2, you're going to graph points A and B on the graph. Perfect. There's a composition I'd like you to perform. Okay, there's a composition there. So right to left, just like we talked about today. Here's the thing. At the end, it says, what single transformation? So what I want you to do is, instead of doing those two, what could I have done right from the beginning to get to the ending segment? All right, so that's what I'm asking for. All right, what, instead of doing it in 2, what could you have done in 1? And hey, we didn't do this today yet, but be specific. Like if you're going to tell me a rotation, tell me how many degrees. If you're going to tell me a translation, tell me up, down, and how many units, left, right. So get specific. And then finally, number 6. For number 6, same type of problem. You're going to do the composition I ask. And then here's what it says for part B. What transformation is equivalent to this? Again, give me 1. Instead of doing these 2, what could I have done in 1 move? Everyone good? And be specific. If you're going to write reflection, what line? If you're going to write rotation, how many degrees? So that's 6 part B. Instead of doing it in 2, what could you have done in 1? All good? All right, go ahead, get going. You guys got plenty of time here. 13 minutes. If you have questions on how to read the compositions, let me know.